Okay, so as you guys are kind of finishing that up, I'm just going to kind of start talking through some of the stuff here. So like I said, we're going to be dealing with the imaginary number stuff we did yesterday. We're just going to combine that and go a little bit further with that. So the first thing we got there, definition of complex numbers. So it says complex number is a number in the form of, they always like it in the form a plus bi. The a is basically just your real number, so like 5, 6, 12, whatever. The bi, then the b is just a regular number, so like 6 or whatever, but then it's going to have the I at the end. That's the imaginary part of it because it's got the I. And then we call it a complex number because it's a combination of regular numbers and the imaginary numbers. Okay, and we're going to always write it in this form here where, like I said, the a value is just our real number, and then the b value goes with our imaginary number, and that's where that I comes into play. Now, there's a whole bunch of properties of these complex numbers because, like I said, some of the normal values hold true, kind of like if it was just a variable, like we were talking about yesterday. But there are some things that kind of change, kind of like these things that we were talking about yesterday, where if you have like an I times an I, it's I squared, but that's also the same as -1. So there are some extra things. So that's that whole property list there. So the first one, it says addition and multiplication are commutative and associative. So that basically just means you can multiply in any order or you can add in any order. So like technically here you could flip those around and still it would be the same addition problem. Same with multiply. And then multiplication distributes over addition and subtraction. So basically that's just saying we can use distributive properties. So if you had something out front of parentheses and you needed to distribute it through, we can do that with imaginary numbers and complex numbers. Next one there, 0 is equal to 0i, or 0 is equal to 0 plus 0i is the additive identity. So that's basically just saying if you add things together and it becomes 0 and 0i, it just cancels out to be 0, just like a normal problem. And then multiplicative identity, if you've got 1 and then 0i, the 0i basically just cancels out and it's just 1. So multiplicative identity is that one. The fourth one, every complex number, a plus bi, has an additive inverse. Additive inverse is basically something you add to it that makes it cancel. So like if we had a positive 5 and a like 5 plus 5i, the opposite of that would be -5 minus 5i. So that would be the additive inverse because they just cancel each other out. And then multiplicative inverse, same thing. Basically, you just do 1 over whatever your thing was, as long as your bottom is not 0, because you can't have 0 at the bottom of your fractions. And we'll do some stuff with that in a little bit with the fractions. And then addition and multiplication properties of equality hold. So if they started equal, they're going to stay equal, basically. Okay, so let's take a look at one of these here. So this goes with one of our properties that we just wrote down here. This would be similar to like the distributive one, right? So right here we've got 7i parentheses 9 minus 6i in that form, a plus bi. So here what we're going to want to do is just think of this just like if it was distributive property and multiply that through. So like if we took like 7i times 9, what do you think that is? Well, what's 7 times 9 to start? 63. And then if this one had an I, 63i, yep. So like I said, it's kind of similar to if it was just a variable. And then if we do the 7 times the 6i, or the 7i times the 6i, yep, 42i, you might have said it squared, right? Because it's I times I, so we'll have minus, because it was minus in between there. The 7 times the 6 is 42. I times I is I squared. And then what do we remember from yesterday, or we wrote it on our sheet today, that the I squared represents? -1, right? So really here, this would be like the minus 42. Instead of that I squared, we can put that -1 in there, right? And then the 63i is just as is. And then here, if we go -42 times -41, wouldn't that just switch that to a positive? Yeah, so it would be like 63i plus 42. And then because here they want us to put it in that form, what do you think we do to this to put it in that form? Nope, thinking too hard. You just switch it around. Yeah, so here, because one of our properties said we can multiply or divide in any, or multiply or add in any order, you can just take those and flip them around so it matches that form better. So you can just put the 42 out front and then plus the 63i at the back. You just want to make sure if like one of them had a negative sign or whatever that those go with it, but yeah, you just flip it around to the order it wants. That kind of makes sense? Okay. One more set of stuff here. Well, I guess one more set for now of stuff to write here. This is going to help us with not necessarily even example 2. I probably should have put example 2 up higher there, but this will help us with example 3, this complex conjugate stuff. So get that jotted down, and then I'll talk you through what's going on with that. Okay, so let's start talking through this stuff. So conjugate, basically all that is when you have something that's a binomial. So binomial is basically where you've got just like 2 letters or 2 things here split by like an addition or subtraction sign. The conjugate of that is basically just switching it from, if it was a positive sign, switching it to a minus sign, or a plus sign, switch to a minus, or you can go the other way. If it was a minus sign, switch it to the plus sign. Okay, so that's what a conjugate is. Now, a complex conjugate is going to be very helpful for us. So it's the same thing we were doing here, where you're just switching the sign in the middle of like whatever your 2 terms are. But what's going to end up happening here when we have these i's, so basically here, if I originally had 3 plus 2i, the complex conjugate of that would just be the same thing, but putting that subtract sign in there. What ends up happening when you FOIL this out is like you'd have like 3 times the negative 2i, 2i times the 3. Well, that gives you a negative 6i and a positive 6i, right? So what happens if you got a negative 6i and a positive 6i? They cancel, right? Because if I got a negative version of it and a positive, those cancel out. And here, if it was I times I, that's I squared, right? And we know from up in our notes that I squared is the same as -1. So we can put that in there with the times the -4 there, and then it'll actually kind of cancel itself out to 13. Okay, so that's a very helpful thing we can use to kind of get stuff simplified out and get rid of some i's and stuff that are going to cause us issues and that we don't want. Okay. So like I said, this one here, it's not really the conjugate stuff, so I don't know why I put this one after the other ones, but it doesn't matter, we'll do it anyways. So this would be a situation where it's just basically like a FOIL thing, right? So if I've got 5 plus 7i times 6 minus 2i, these would not be complex conjugates. They are both complex, but the numbers here aren't the same, even though one's plus, one's minus. Since the numbers aren't the same, it's not going to work exactly like that one, but we can still do some simplifying here. So I would do our FOIL stuff. So F for FOIL's first, so I'd go 5 times 6, which would be 30. O for FOIL is outside, so that would be 5 times -2i, so that would be -10i. I is inside, so it would be 7i times 6, which would be 42i. And then our L would be last. It would be the 7i times the -2i, so that would be -14. And then I times I would be I squared. Then I would do some combining, because we know these are both i's, right? So we could put our two i's together. So that would be -10, 42 would be 32i. Can drop down that 30 I had before, and it would be plus 32 because it would be positive 32. And then here, just like we had before, so if I've got minus 14, what was I squared the same as? -1. And then if I swap that out for a -1, well, this would be -14 times -1, which would make that positive 14, right? So now I have 30 plus 32i plus that positive 14, and then I can even go one step further than that, right? Because now if I did that out and got rid of that I squared, well, now I've got a regular 14 and a regular 30, so I could probably put those guys together and make 44. And I'm going to make sure I write it in my proper form the first time here. So if I go 44 out front plus 32i, that would be in that proper a plus bi form. Okay, let's try another one here. This one we are actually going to use the complex conjugate stuff. Okay, so when you have a situation like this where it's like a fraction and they ask us to simplify, this is where that complex conjugate thing is going to get mixed in, because basically we want to try to get rid of kind of this messy stuff down here and make it kind of go away. So I'm just going to rewrite this down here so it's a little bigger. So 5 minus 2i over 3 plus 4i. And our goal is to make the bottoms go away and just have like our I value on the top. So we need to make this guy go away or just turn it into like a regular number. Okay, so like I said, this is where we're going to do the complex conjugate thing. And what we're going to do is we're going to multiply by the same thing on the top and the bottom. Okay, because if we multiply by the same thing on the top and the bottom, that's equivalent to 1. Okay, so like it was 5 over 5, that's the same as 1. So here we want to take and figure out the complex conjugate of this, which is basically just taking this number and putting the minus sign in the middle. So it would be like 3 minus 4i. And then again, whatever we do to the bottom, we got to do the same exact thing to the top. So 3 minus 4i to the top as well. And then this is where it gets kind of sucky because you actually have to do like FOIL for the top and the bottom here. So what I'm going to do is I'm just going to do it kind of off to the side. So I'm just going to do like 5 minus 2i times 3 minus 4i. Oops, FOIL that guy out, just kind of off to the side. And this is for the top part of our fraction. So 5 times 3 would be 15. Outside, 5 times -4i would be -20i. Inside would be -6i. And then last would be positive 8i squared. And then we could put our middle i's together there, right? So that would be -26. So 15 minus 26i. Here we know it'd be 8 times I squared is equivalent to -1. So let's throw a -1 in there. And then we know that times 8 times -1 would be -8. That's 15 minus 26i. And then again, kind of similar to before, we could put that 15 and that 8 together. So 15 minus 8 would be 7. So in that form, it would be 7 minus 26i for what the top kicked out. So let's do suppose let's do that on the top. So 7 minus 26i. Then we're going to want to do the same thing on the bottom. Leave myself a whole lot of room here. So on the bottom, we'll do the same thing. We got to FOIL that out. And again, because we did that as the complex conjugate, our stuff should cancel out, or some stuff will. So 3 plus 4i times 3 minus 4i. So first, 3 times 3 would be 9. Outside, 3 times negative 4i would be negative 12i. Inside, 4i times 3 would be 12i. And then last would be 4i times negative 4i, which would be negative 16 I squared. I don't know why I put a parentheses there, you don't need that. And then, like we talked about, the middles here on our complex conjugate ones are going to cancel out because that's why we selected this method. So then we'll just have a 9 out front there. And then here, this would be like a negative 16 times. We know I squared is the same as negative 1. And then we know a negative times a negative would make that like a positive 16, right? So 9 plus 16, and 9 plus 16 is 25. So 25 would be the bottom of our fraction. So we're getting close. So then what they're going to want us to do is they're going to want you to write your final answer in that a plus bi form. So basically we want to separate like the I to its own deal here. So both of these values are out of 25. So what you're going to do is you're just going to take the 7 and put it out of 25 minus the 26 out of 25 with the I with it. And that's just to put it in that a plus bi form. Okay? But that's what they're looking for their answer on that one. That's the final answer, yep. Okay, and then we got one more set of stuff to write here. This isn't in your packets, is it? The electrician stuff? Okay, so get this electrician stuff jotted down then, and then we'll talk about that. But we need it for the next example and for some of them on your assignment. You gotta have this electrician stuff. It's technically it's II. Capital I for current, small I for imaginary. Okay, so this imaginary number stuff actually has real life applications. So they use it a lot with electricity and like electricians. So here, and I don't know a whole lot about electricity, but basically our form here for Z is going to be electrical impedance. That's going to be Z. V is going to stand for our voltage, plus our I is going to stand for our current, and then our current is going to have our I value with it, or our imaginary value. There's two different types of ways that they can run, like lights and that kind of thing. So one is, do you guys know the difference between series and parallel electricity? So series is kind of like where it's like a Christmas light strand. So like you got like power here, and then you got like your light bulbs going around. What happens with something like this when one of your light bulbs goes out? They all end up going out. So like if this one goes out, everything past that also goes out because your power is getting like cut off right there. So that's why like if one goes out, they all go out. Where parallel is different. So parallel, how that works is you got your power here or whatever, and then you've got your lights on their own individual things here. So like even if this one went out, the power can still get to these other ones and run through it. Okay, so that's kind of the difference. Series is like Christmas lights. The other one, parallel, is more like probably just like regular lights. Okay, so what they tell us here is they want us to find the total impedance, which would be like our final Z value, I think. And it says in a parallel circuit, so we're going to use the one for parallel. And they tell us our Z1 is 1 plus I in ohms, and then our Z2 is 2 minus 6I in ohms. Okay, so we're going to use this formula here, plug in the stuff that we know. So like here we know that Z sub 1 is going to be 1 plus I, and then our top in that situation is multiply, so we're going to multiply that by 2 minus 6I over, and then the bottom they want us to take those two values, the Z sub 1 and the Z sub 2, and add those. So 1 plus I plus 2 minus 6I for the bottom. So the first thing I would do is I would kind of start simplifying this down here. So like our top there, we're going to have to do FOIL because that's a multiply one, right? So just off to the side here, I'm going to do FOIL. So 1 plus I times 2 minus 6I. So first would be 2, outside would be negative 6I, inside would be 2I, last would be negative 6 times I squared, and we know I squared is the same as negative 1, right? So really it's kind of like times negative 1. Here we'd have 2, I would combine together my 6I and my 2I to make negative 4I, and then there it would be like negative 6 times negative 1. And we know negative 6 times negative 1 would make that a positive 6. So 2 minus 4I plus positive 6. Then we can put the 2 and the 6 together to make 8. So our top would be the same as 8 minus 4I. So 8 minus 4I on the top. And then our bottom is just addition, right? So we know with addition we can just combine our stuff as is. So like you could put your 1 and your 2 together, right? So 1 and 2 would make 3. And then if it's I and negative 6I, that would make negative 5I. Now the sucky thing is, because we still have this I on the bottom here, we do have to do the complex conjugate thing to make that go away. So what you're going to do is you're going to multiply everything by the opposite of this bottom here with the plus sign. So you're going to multiply it by 3 plus 5I, and whatever you do to the bottom of your fraction, you also want to do the same thing to the top. And then now we have to do a bunch of FOIL again, which sucks. So that was one of our FOILs. I'm going to do the top first here. So it would be 8 minus 4I times 3 plus 5I. And again, it sucks because we got to do FOIL out. But our first would be 24. Outside would be 40I. Inside would be negative 12I. Last would be negative 20I squared. We can put the i's together there, so we'd have 24 plus, what would that be, 28 I, and then the back, that would be negative 20 times negative 1, which would make that like a positive 20. And then we could put that with our 24, so 24 and 20 would make 44 plus 28I for our top. So top is now 44 plus 28I. And then the bottom you would just foil out again. The bell's going to ring here, so I'll just give it to you. The bottom you would also foil. It'll end up being 34. When you do that out, I'll finish it out and scan it for the notes. But then you do the same thing where you break it up like we did that other one to 44 over 34 plus 28 over 34 with the I. And if you want to reduce it down, you can, but you don't have to. But that could be our answer there. Okay, like I said, the bottom I'll foil out and put it on the notes and I'll scan it, but the bell's gonna ring here on us. So I'll finish this out, scan it, and put it up for you, okay? All right, sorry we cut it so close, but I'll get that scanned up there. So that book page for tomorrow, and then we'll keep going with some more of this I stuff tomorrow.